Assalamu alaikum guys, welcome back to the AS chemistry crash course. Okay, so we finished off at moles in lecture 14 in the previous lecture. Now we are starting out a new chapter, chemical bonding, in this lecture. Okay, lecture 15 of our AS chemistry crash course. Okay, from your O levels you know that covalent chemical bonding is of three major types: ionic, covalent and metallic. Okay, and the covalent bonding, now whenever you are asked, and by the way covalent also has a special category now, it's called the dative bonding or coordinate covalent bonding. Okay, dative bonding or coordinate covalent bonding. Okay, and the normal covalent bonds, the traditional covalent bond that you guys have already done since O levels and in A levels as well. Ionic bonding and metallic bonding are pretty much the same as you guys did in O levels, but this covalent bonding has a bit of extra details that we'll be covering in the later videos when we'll be doing each one of them individually. Okay, ionic bonds or ionic compounds, whenever you are asked to define the structure of ionic compound, remember the key term that you need to use is that ionic compounds are all giant. Okay, this is the key term, they are giant. They have a giant ionic lattice. Okay, the structure of ionic compound, this is the structure of ionic compound. Okay, do not say that they have an ionic structure, or do not say this they have an ionic lattice. For example, if you are asked to define or explain or describe the structure of sodium chloride and the types of bonds it contains, you do not say that it contains ionic bond. Just saying ionic bonding over in O levels was sufficient, but over here you cannot say that, because it doesn't only contain ionic bonds, rather it contains a giant ionic lattice. Giant ionic lattice means that there are thousands and thousands of ionic bonds linked together by one another, linked together with one another, linking many thousands of ions. Okay, that's why it's giant. So whenever, even if it's magnesium chloride, it's still giant ionic lattice, right? Magnesium chloride. Even if it's some other thing, like for example, well, this is ionic with some covalent characteristic. Okay, magnesium chloride, that's an exception, but still it has a giant ionic lattice. If it's magnesium oxide, again giant ionic lattice, a huge ionic lattice, because it has a very high melting point because of the extremely high amount of ionic bonds which are present in there, due to which it is used to line furnaces. And this use of magnesium oxide is very high yield, because it has been asked on the past papers several times, this application, even in O levels as well as in AS. Okay, and so on. All the ionic compounds which are ionic in nature, they contain giant ionic lattices. Okay, now coming to covalent compounds. Covalent compounds can contain two types of structures. They can either be giant covalent structures like the ones which you guys have already done in your O levels, in addition to a few extra ones which we'll be doing here, or they can be simple covalent compounds or simple molecular compounds. These are also known as simple molecular compounds. The giant ones include diamond, graphite, both allotropes of carbon. I hope you guys remember what allotropes were. Silicon dioxide, SiO2, allotropes of carbon. These are allotropes of carbon, Okay, allotropes are actually alternative forms of the same element. Okay, this is simple covalent compound. Remember, you guys had some simple structures. For example, you had let's say the halogens of the periodic table have a simple covalent structure, or for example you've got the let's say HCl or HX acids, the halogeno acids, they also have a simple covalent structure, etc, etc. Okay, but halogens are the classical examples of being simple covalent. Okay, then comes metallic bonds. So metallic bonds are the bonds which are present only in metals. And what sort of bonds are they? They are basically a force of attraction between positive metal ions and a sea of delocalized electrons. So this, and metallic compounds also have a giant metallic structure. Okay, it has a giant metallic structure, not a simple metallic, not a simple covalent, but giant metallic structure. Okay, And if you were to describe the metallic bond, if you were to ask to describe the metallic bond. Now guys, the structure of metallic compounds, the question regarding to describe the structure of metallic compounds and the question regarding to describe the metallic bonds themselves are two different questions, okay? If you are asked to describe the structure of metallic compounds, then they are giant metallic structures. They have a giant metallic structure, or giant metallic, I should say giant metallic lattice, okay? Giant metallic lattice. What is a lattice? Lattice is basically a regular arrangement of atoms or particles being arranged, being repeated again and again, okay? Giant metallic lattice. Now apart from that, if you are asked to explain what metallic bonds actually are, so they are basically a force of attraction between positive metal ions and a sea of delocalized electrons. You guys have already learned about that in your O levels as well, and the same applies here, that this is a force of attraction between positive metal ions and the sea of delocalized electrons. And that's it guys for this video. In the next video we'll be talking about each one of them in detail, okay? Thank you so much.